We're delighted today to be featuring in our virtual company showroom ISIS, the Neutron and Muon Source, which is based at the STFC Rutherford Appleton Laboratory in Oxfordshire, UK. It's a world-leading centre for research in the physical and life sciences. It's owned and operated by the Science and Technology Facilities Council, so STFC. Now, we're privileged to have several panelists joining us from ISIS-STFC, so you'll get to meet them all in the discussion. But first, I'd like to introduce you to our speakers, Galen Aymar, who is the Accelerator Design Group Leader and not a relation of Robert Aymar, former Director General, I just discovered. And then also Catherine Amy, who's a Senior Resourcing Partner. I think I can hand over to you, please, guys. We'll start off with the presentation and then we'll have questions and a panel discussion.
So as Rachel mentioned, my name is Galen Aymar, and I'll be presenting along with Catherine, who will come in at the end of this presentation. And I'm the Accelerator Design Group Leader at the ISIS and Neutron and Muon Source. So thank you for coming to this. Hopefully it'll be educational for you. So for a bit of background, the ISIS Neutron and Muon Source, as was mentioned, is located at the Rutherford Appleton Laboratory in Oxfordshire. And so at the lab, we have several different science facilities in addition to ISIS. So for instance, there's the Aral Space Facility. There's a Diamond Light Source, which is an X-ray synchrotron. We also have the Central Laser Facility. But most importantly for this talk, we have down here the ISIS Neutron and Muon Source. So as it clearly states in the name, ISIS is a neutron and muon source, and these neutrons and muons are used to study materials at the atomic level. We have a suite of, which I'll talk about in more detail later, 31 different scientific instruments that visiting scientists can use for studying samples of materials, biological samples, man-made, natural, that kind of stuff. And so we're really a world-leading materials science research center. We serve the UK and the international scientific community, so we're not just restricted to the UK. And a bit of background on why we use specifically neutrons in this case. So X-ray synchrotrons, which are common around the world these days, actually work in a fairly similar way to the neutron source, but the X-rays interact with molecules or atoms differently than neutrons. So in this little chart here, I'm showing roughly by the size of the sphere the interaction that an X-ray has with various elements, and it's roughly proportional to the atomic weight. Neutrons interact with the nucleus via different mechanisms, and it's not proportional to the atomic weight. So you can see neutrons would see hydrogen far easier than an X-ray would. So you can look at materials in a different way, and it's a complementary process to X-ray scanning of these types of materials. So at ISIS, we have 29 neutron instruments, and we have 5 muon instruments in total. Each year, we receive thousands of proposals with thousands of scientists visiting from both the UK and around the world. We'll typically run about 1,000 experiments in a year, and from those experiments, publish about 600 journal articles. So we're putting out lots of good science at ISIS. And the sort of employment look at ISIS. So the demographics, we employ people from all around the world, from every continent. So it's definitely not an insular sort of facility. We have all kinds of people from all walks of life, which is fantastic. And then if you're a technical role, we employ people in pretty much all areas of technical expertise. So fairly evenly distributed between engineering, science, computing, and technicians, with a small amount of safety in there as well. There's then a separate group that handles HR and administration of facilities, that type of work. But if you're involved in any of these, this talk should be extremely interesting to you. So a bit of background on ISIS. It was really the first large-scale particle accelerator-driven neutron source in the world, and kind of spearheaded this type of science. Since then, other facilities have come online, and others are being planned to come online. So this is showing accelerator-driven neutron sources around the world, really the ones that exist or are coming online. So it's now become an international field, and we work closely with each of these facilities, the scientists, the physicists, the engineers at all these facilities in collaborative efforts to help us and help them. So when working at ISIS, you also get the opportunity to work with all these various facilities, in addition to the other types of accelerator facilities you would expect anyway. So to dig into a bit more detail on what ISIS is and how it works, I've got here on the right-hand side a picture of a schematic of the ISIS accelerator and the target stations overlaid on top of a bird's eye view of the buildings, so you can kind of get your bearings a bit. And basically, ISIS utilizes a proton beam that's been accelerated to a particular energy to impact two target stations, which are shown here and here. And when it hits those targets, it generates neutrons or sometimes muons, which then radiate out into instruments to be used for science. So quick overview we have up here. This is where everything starts. This is our ion source. We actually start with negative hydrogen ions, which are accelerated through a linear accelerator. This particular linear accelerator has an RFQ and a drift tube LINAC. It's then the hydrogen ions are then injected into the synchrotron where they're converted into protons. And those protons are accelerated around the synchrotron up to 800 MeV. And then they're extracted pulse by pulse and sent to target station 1 over here or target station 2 over here. I should mention right here is where neutrons are generated, as I said, into the instruments. We also have a muon target. Right here, the beam passes through a muon target and generates muons. So we have a small suite of muon instruments as well. The second pulse is then sent to target station 2 with a newer, different set of instruments. So I'll take you through kind of a walking photo tour of ISIS so you can see all of it in detail, starting with the linear accelerator. As I mentioned, we have an ion source, which is a smaller component. We immediately go into an RFQ to do the initial acceleration. Here's a picture of the RFQ on the left-hand side. If you're familiar with these at all, you might recognize that there's these 4 undulating veins running the length of the vacuum vessel that do both focusing and acceleration. We then pass it into a drift tube LINAC, which accelerates the beam up to 70 MeV, and 70 MeV is roughly equivalent to about 40% the speed of light. And here's a picture of the outside of the drift tube LINAC. This is the inside as we're building our new drift tube LINAC with each of the drift tubes hanging inside of it. From there, as I mentioned, we inject the H- ions into the synchrotron and convert them to protons. The synchrotron consists of 10 super periods. It's about 50-meter diameter, 10 periods. So there's 10 dipole bending magnets, which bend it around the ring. And then there are quadrupole magnets situated throughout the ring as well that do focusing. So our magnets do bending and focusing. This here on the right is showing one of our large dipole magnets. We then have a series of RF cavities that accelerate the beam. And this here is a picture of one of our RF cavities that does the acceleration all the way up to 800 MeV, which is roughly equivalent to about 80% the speed of light. I should point out the unique thing about our synchrotron is that it's a rapid cycling synchrotron. So the accelerating cavities and all of the magnets have to remain in sync, and they ramp up to full power and back down 50 times a second. So it's a very quick ramping. So we're doing 50 different pulses every second to our target stations to generate neutrons. So a very fast cycling, a rapid cycling synchrotron. So as I mentioned, these protons are accelerated and then sent to the target stations. The target stations are massive, but the actual targets are relatively small. This here is showing the tungsten target on target station 2. And this in this particular instance, it's a solid cylinder of tungsten. The protons coming from the right hit this tungsten and through the spallation process generate neutrons. There are then 2 other key parts of the target facility. We have these blocks here which contain moderating materials. So the neutrons pass through these blocks and the moderating materials slow them down and then reduce their energy to an energy that's useful for the scientists. Otherwise, as they are, the raw neutrons are going too fast to be useful. We then also have beryllium reflectors, and this is actually 1/2 of a reflector shown up here, just a massive chunk of beryllium with ports cut open to it in it, and those focus the neutrons into the direction of the instruments. So we have similar looking facilities on target station 1 and target station 2, and these have supporting plant and cryogenics and electronics and all that and controls to maintain these targets. So if I were to zoom out of the target station, that was a zoom in view of the target itself. When we look at the target station as a whole, this here is target station 1 on the left and target station 2 on the right. And so they're large buildings and large facilities. To get your bearings, underneath all of these concrete blocks is the proton beam coming from the left to the right, and then it hits target station 1 right there. Similarly on target station 2, the proton beam's coming from the left to the right through this sort of tunnel, and the target is mounted right in the middle of this sort of circular structure. And from there, the neutrons radiate out radially into the neutron instruments, which are shown sort of in these blockhouses, these colored blockhouses here. And there are several instruments that are sort of hidden away in target station 1. And this is really the key of ISIS, where all of the science itself is done. So to focus a bit on the science, which is sort of the entire other half of ISIS, as I mentioned, we have in total 34 instruments. Here I'm just highlighting 4 of the instruments. On the top left is an instrument that we use for measuring, magnetic field and special magnetic properties in materials. On the top right is an imaging instrument to take images and pictures of materials using neutrons, so you can see different materials than you would normally through an X-ray. On the bottom right is a instrument that's used for cultural heritage studies, and on the bottom left is one of our muon instruments. And so all the scientists pictured here are both internal and external scientists. We have a large group of internal scientists that help to run and facilitate experiments for external scientists on the instruments, but then they may also run their own experiments as well. And then visiting scientists from all over the world and the country. So that's a bit about how ISIS works and what it's used for. I then want to go through a handful of slides that discuss the types of opportunities and types of work that we have specifically for people at ISIS. So starting with the accelerator physics side. So the accelerator physics group really has ownership of the entire accelerator. That's including the LINAC, the synchrotron, and the transfer lines. So one of their key important tasks is beam commissioning and startup after shutdowns and before user runs. During this stage, we also can have a machine physics studies, which is really sort of maybe the best part for an accelerator physicist. This is where they can take their theory and their modeling that they've been working on, and then actually do measurements on a real machine, get data out of that, do analysis, and sort of close the loop on their physics studies and analysis and theory. So it's a fantastic opportunity to work on a real machine. And then once the machine's running and the users are actually running experiments on it, there's machine supervision. So when we're running, we have to keep running 24/7. So that means as soon if the machine trips off at any moment, there has to be somebody there with expert knowledge to get it back running again. And there's a great opportunity to collaborate with all the different functional areas of the site. And then there is new R&D. So we have a separate beamline, offline beamline called the front end test stand that we're using for new R&D. And then we're also in the beginning stages of developing ISIS-2, which will most likely be an all-new accelerator facility built and designed from the ground up. So that's a very exciting opportunity. We then have a large beam diagnostics group as well for the accelerator, and they operate and maintain over 250 different devices across the entire complex. And so these are things for doing machine development and tuning and beam protection systems as well. They both maintain the existing hardware, some of which is shown here, and they're constantly developing new hardware for higher reliability or different performance. There's also a software side to this, which is analyzing the data that you get from these diagnostics, and then constant R&D, both for improving the diagnostics on the existing accelerator, but also doing R&D on diagnostics for the new ISIS-2 type of accelerators that we're looking at. If I move into design engineering, engineering at ISIS is fantastic because it's really full project lifecycle of bespoke equipment. So each of our engineers will be involved on their projects from concept through theory and design to assembly, build, test, and implementation. So you really get to own the entire process, and we do the assemblies here on site. Design engineering is roughly broken up into 3 different areas. The accelerator, which means you could be involved designing new beamlines for upgrades to ISIS, working on magnets, accelerating cavities, and diagnostics, and then also the chance to work on the ISIS-2 designs. We then have a targets group, which works with these highly specialist material targets, high heat loads and pressures and cryogenics, and also is developing new targets for ISIS-2 and other facilities. And then our instruments group, which is actually our largest group, and they deal with those 34 instruments plus additional new instruments. So for instance, on the picture down here, they're actually looking at a new neutron detector that they're designing and trying to implement. And they'll also be designing neutron choppers, motion control, sample environment, and then the entire instrument itself. And they've got the opportunity to work on Endeavor, which is a project we've just been kicking off, which is to build a suite of, I think, about 8 to 10 brand new instruments to upgrade our facility, and then eventually moving on to ISIS-2. Electrical engineering is expansive at ISIS, so it can cover anything from motion control to power distribution to RF. On this particular slide, I'm focusing on magnet power supplies. And for magnet power supplies, we obviously have quite a few, and they're separated into sort of three different main groups. That's DC, AC, and pulsed power supplies. So it involves project management of new power supplies and procuring new ones, perhaps designing some of our own bespoke equipment, trying to do increase our reliability with FMEA, that's failure mode and effects analysis and machine learning, develop new power supply technologies where we're really at the forefront of advanced pulsed power capabilities, and then working on other sort of sustainable alternatives for our power supplies and how we can run more efficiently. There's then a very large software side to ISIS. Any facility that generates data has got to do something with it. So I've split this up into sort of two different categories. There's we'll call it full stack web apps, which is really the group handling sort of the business end of our software. And these are, user databases, beamline request systems, scheduling systems, experimental data management, that sort of thing, and a lot of web-based applications. We have developers that are both front end and back end. So if you have a preference of one, we do both. You can do both or specialize in one or the other using a whole different suite of tools at our disposal. We then have another group that focuses more on the scientific software. And so they're developing and maintaining these data reduction tools to turn all of this data into something useful for the scientists so that they can visualize and analyze their data. And that requires developing new algorithms and architectures, evolving how we do this sort of data analysis. And so if you tend to be a bit more interested in the application side and the science that's being done at Neutron, this is a fantastic way to get involved in both the programming of the software and the science itself. And just to sort of show off some of the computing stuff that's here, because it's a bit harder to visualize with pictures, these are the various types of apps and data analysis software that we've got shown here. So for instance, here is showing a heat map of a neutron detector and where neutrons are being detected. And here's some, neutron images of a sample with different filters and things applied to it. So a sort of fantastic amount of work for a software developer. And then with that, I wanted to share a quick video with you, which is just a few of the people working at ISIS talking about their experiences. So if you bear with me for just a moment.
So I'm the group leader for scientific software in ISIS, and we kind of look after all of the software development for the facility to do with the experimental data and analysis and converting it to something that scientists can use. So the thing I enjoy most about that is it kind of feels like you're close to the science and you're actually making an impact on what the users can do with the data, and you feel like you're all part of that research process. So it's really quite nice.
So here at ISIS we have a very dynamic environment, which means that one week I can be working on operations and the next week I'm working on theory. So every week is very different from the other. So I've been here for about a year and a half, and ISIS, as soon as I arrived, seemed to me like a very progressive and forward-thinking environment. So it's really nice to work in an environment where most people are actively trying to improve things.
If I want to get involved in training, learning new things, the answer is always, yeah, go for it. As long as it fits into your schedule, we'll make the time for it, we'll make the budget available for it to develop you as a good engineer.
It's been really good working here because compared to my previous roles in the private sector, I feel like I've been able to progress quite quickly. And that's been because ISIS and the STFCs provided quite a lot of training. They do provide a lot of training. There's a huge focus on training within the organization, which is great if you take advantage of it. And it just allows you, people give you chances all the time, and it allows you to progress very quickly.
Since I have arrived, I've been given a lot more responsibility than I have in the past, and that has given me a lot of opportunity to learn and to grow and to develop.
I found that career progression has been really good here, so when I've wanted to move forward in my career, I found that line management's really great at working with me on identifying areas of weakness, making sure that the opportunities are there so that I can develop myself in those areas so that the doors can sort of naturally open to progress. They're always really supportive in making sure that you've got all the boxes ticked to make sure that you're ready to go on the next level if that's what you want.
Management encourages good boundaries between work and life. And we have good flexible hours, so if people need to leave to collect their children, etc. from school, that's a very common thing. And we also have a good balance of working from home and working in a lab.
A huge benefit for me is the flexible working system that we've got here. So not just the flexibility in the hours that I work, but also the flexi leave. So as a new father, being able to vary my hours to fit around my family life is really important. And the fact that I can build up extra hours and then take off extra flexi leave on top of my annual leave means that I get to be around to see all those key milestones with my son as he's been developing. And that's been really fantastic for me, and I made a huge difference in this first year of his life.
Great, so hopefully that was informative. And then I was going to hand it off to Catherine to sort of take you through the actual recruitment activities that we have going on.
Brilliant, thank you, Galen. So alongside all the opportunities that Galen's sort of given an overview of what we have in the ISIS facility, we really just wanted to highlight some of the opportunities we have available right now and also some of our upcoming opportunities. So we've got some really exciting ones out at the moment. So we've got some group leader roles within our mechanical engineering division, senior lineup physicist, some power supply engineering roles, electrical controls engineers, and many more opportunities available right now. And the other thing to note is that ISIS is undergoing some huge developments and some huge projects. So if you're not looking for a role right now, or the role that you would like to look at is not available right now, it's very likely that in the future that you'll see this role come available as we continue to grow our talent and continue to grow our employee base as well. The other thing I really want to flag to you is that we've recently launched 3 new talent pools for software engineers and developers, mechanical engineers and electrical engineers. The really great thing about these talent pools is that our recruiting managers will often review candidates within the talent pool before going out for their full external advert. And the other benefit of the talent pool is that we're going to be shortly launching newsletters going out to people in the talent pool, which give you an overview of all the roles available, not only just within ISIS, but across STFC as well, which match your skills and experience. So a really great opportunity to stay in the loop with all the opportunities we currently have available. So moving on to talk a little bit more about benefits. So you would have heard about some of our benefits in that video that we just showed. And we are really lucky that we do have a really broad range of benefits within the organisation. So I'm going to touch on a few of these today, but it's really important to note this isn't all of them. We've got loads more available as well. The one that I think is really great is the ones that do align to work-life balance. And we do have some really incredible benefits to support a really healthy work-life balance at ISIS. So we do offer for full-time employees 30 days annual leave per year. In addition to that, you also get the 8 bank holidays, 8 UK bank holidays. And on top of that, you get 2.5 what are known as privilege days, but they're basically additional 2.5 bank holidays. So a full-time employee would get 40.5 days leave per year, which is really, really great. The other thing that we have available, which you would have heard mentioned in the video, is flexible working hours, which gives you the opportunity to work your weekly hours in a way that better suits you. So whether that's working around sort of family life or school pickups, we've got the opportunity to offer you that flexibility. In addition to that, if you do work over your weekly hours, then you've got the opportunity to take that time back, whether it's an afternoon off or a day off, as flexi leave. So on top of your really, really great annual leave, you've also got the opportunity to take flexi leave as well. We also have some other paid leave that we do offer our employees. So that's like parental leave. We have a really great enhanced maternity leave pay packet that we offer. And we also do offer special paid leave for any additional days that you might need to take. And we also benefit from an on-site subsidised nursery, which is a really great benefit. On top of ensuring good work-life balance, we do want to help and support your health and well-being. So we've got a few initiatives in place in order to do that. So these include things like the Cycle to Work scheme, which ensures that we have that gives you tax relief off the purchase of a bicycle. We have on-site sports facilities and a RAL Recreation Society, which basically gives you access to those sports facilities. But they also put on a huge range of social events, which gives you the opportunity to not just meet people within sort of ISIS, but further out across the campus as well, which is a really great thing to do. We have access to confidential counselling service, which is available 24/7 to all our employees. And then we also offer a discount scheme for things like high street vouchers, grocery discounts and travel offers as well, which is really great. Another good benefit that we have, which is not always available, is free car parking on site. But you can also see from the pictures which are available on here that we do also have great cycle links if you do want to cycle to work. And we also do have great bus links to the campus as well. So it's quite a really easily accessible site. Some further benefits that we have available. So contractual benefits. The majority of the contracts that we offer at the ISIS facility are permanent. You'll sometimes see them referred to as open-ended, but they're one and the same, they're permanent contracts. We also have a really great defined benefit career average pension scheme. And then once you're working with us, there's a few other schemes which we do have available, which are really great. So we have an employee recognition scheme, which recognises colleagues for showing that they're really adhering to our core values. We have employee referral schemes, which give you the opportunity to bring people into the organisation that you think would be great for the role, and then you get a financial reward if you do get somebody in for us. And then a really great benefit if you are relocating is our rent deposit salary advances. So we can offer you an upfront loan for rent, and then you can just pay that back through your monthly pay packet. Some additional allowances that we have available. So some of our roles, we are able to offer relocation allowances, which is obviously great if you're moving across to the UK. We do have most of our roles across ISIS do attract specialist role-based allowances, which are paid as well. So you will see these advertised on our roles when you look on the careers portal. And then some of our roles also do attract potential on-call and shift allowances as well. Another thing that's really great that we do offer is immigration support. So we have a really fantastic and very knowledgeable immigration team within our organisation who can support you through any sort of visa application, any queries around visa processes. And the majority of our ISIS opportunities do attract visa sponsorship. So if you do see a role of interest, it's more likely than not that we're able to offer you sponsorship for a skilled worker visa. In addition to that, we do offer reimbursement of your visa fees, and we do also offer support for dependents coming across to the UK with you. So our ISIS facility is really dedicated, and we really strive for an open and inclusive work environment, ensuring that we offer equal opportunities for all. So these are some of the accreditations that we're affiliated with, and it's really just a testament to the work that we do to ensure that we have a positive working environment. And we're really striving to build a culture that values openness, fairness, and transparency. So I know you'll have a lot of questions probably from your side at the end. We just wanted to cover off a few of our frequently asked questions for you to give you a bit of a starting point. So how do you apply for our vacancies? So majority of our roles you should see on the CERN Alumni job board. And when you click through those, they'll link you through to our careers portal page where you can see our full range of opportunities. When you apply for our roles, what we ask for is an up-to-date CV and a cover letter, which showcases your skills in line with the criteria that you'll see on the role description. How are your applications processed? So the majority of the time you won't hear from us until after the closing date. So applicants are reviewed and scored against our shortlisting criteria, which you would see listed in the job description. If you're successful past the shortlisting stage, you'll be invited to an interview with us, and that's either via Zoom or in person. And then at the interview, you'd be assessed against the set interview criteria and scored against this as well. And then finally, the top scoring candidate is selected for the role. If you need sponsorship to work in the UK, we do offer sponsorship support, and the majority of our opportunities are open to visa sponsorship as well. If you're successful and you require a visa, we'll support you through this process. We do understand it can be confusing, and there's often a lot of questions that come out of the process, so we're here to support you with that. And in addition to that, a few of the team members within ISIS have been through the process themselves, so they can offer some really great advice when you're going through that process. You'll also be able to claim back your visa fees after you joined us. The other support that we do offer is relocation support. So if you're moving across to the UK, we do offer a set amount that you can reclaim back once you've started with us. So that's a really great benefit. In terms of hybrid and remote working, so due to the nature of our roles, the majority do require on-site presence. So sort of fully remote working is not always possible. For some of our opportunities, sort of like software development roles or software engineering roles, sometimes we can offer a bit of a hybrid working environment, but it's not always possible for all the roles. But for the roles which are site-based, employees can work from home on an ad-lib basis on agreement with their manager. So if you need to be home on a one-off basis, then obviously we can discuss that and you can agree that with your manager. And then finally, how do you find out more? So obviously Galen's given a really good overview of the ISIS facility, and it's given you some really good starting points of information. If you want to dig down any deeper into any more of our departments or any of the projects we're working on, learn a bit more about Endeavour or ISIS2, please do visit our website where we've got some loads more information for you on there. And we'd also really encourage you to follow our LinkedIn page, where we provide a lot of news and updates coming out of the facility. You can kind of stay in contact with us through that as well. So thank you. That's all from our side. So alongside Galen and myself, we also do have a couple of other panel members from the facility, which are here to sort of answer any other further questions that you may have. But yeah, I'll pass over to you in case there's any questions.
Thank you so much, Galen and Catherine, for such a comprehensive and informative presentation. I mean, I'm quite interested. Looks like a great place to work. It really inspired me. So yeah, we've given us a great overview of the ISIS Neutron and Muon Source. So I also see that Haroon is there, who's a CERN alumnus. So people might want to also ask him questions directly about what it's actually like to work at CERN. Let's open the floor now to questions.
Thank you, Aymar, for your presentation. Just a question concerning the energy of the neutron beam that you sent to the target. Are they slow neutrons or fast neutrons? And which is the background in the laboratory of neutrons? Thank you.
So yeah, it might not be the best to answer the question, but the proton beam going to the target is 800 MeV. We then slow the neutrons down that are generated from the target. I suppose I'm not totally familiar with the nomenclature, but usually on single digit EV, milli-electron volts in EV, so cold neutrons, sometimes warm neutrons. I'm not sure about what the background level is though.
The slow neutrons are very penetrating to the material, and they create a lot of damage. Thank you.
Yeah, thank you. John, did you have something else to add?
I was just going to say something a little bit more about neutron energies. So typically the neutron energies after moderation are in the tens to hundreds of milli-electron volt range. So they're not very deeply penetrating and not very damaging. But we do have one beamline that takes full energy unmoderated neutrons in the hundreds of mega-electron volt range. And those are specifically being set up to mimic damage to electronic components and so on that's caused by cosmic rays.
So we have a question now from Chiara. Chiara, would you like to come on camera and ask your question, please?
Yes, thank you, first of all, for the presentation. It was very interesting to hear about all these details. My question was correlated also to a person that we saw in the video who mentioned that he was previously working in the private sector and then coming to you. So I'm interested about. So I think that in this case the transition from CERN or science to your lab is more straightforward than going to industry and then coming back. So if you can say something more about this. Yeah, how this transition can happen in a smooth way. What do you expect? Yeah,
definitely. So I think Lamar might be in the meeting and might be able to answer directly.
Yeah, I'm here. Yeah, so that was mainly to describe, there's a very big difference between, working for a profit in a profits-driven environment versus working in an environment where everyone's kind of collaborating for the scientific outcomes. So in a sense, it will feel very familiar to someone who's working working at CERN. I mean, we all kind of pull together. It's a very flat organizational structure in terms of the way teams work together and so on. It's not, hierarchical, for example, like maybe in a private sector company. So it's just, I don't know. I would say it's a really relaxed place to work. I don't know if anyone else wanted to.
Can I have a follow-up question to you? So what, if I can ask, what did you do before? So in the private sector, what was your role and how did you decide to move again?
Yeah, so it was software development in a scientific context, but it was mainly for kind of, I'm probably not supposed to talk too much about it, but it was mainly for like defense kind of applications and a few kind of life science applications, but it was really geared towards, the company being able to sell cameras essentially. So it was, it was a very small company as well. So there were like 50 people. So everything felt like a crunch all the time. And, people were incentivized with bonuses and stuff, but it was quite a difficult environment to be in, constantly pushing for the profit, because every month it felt like what you were developing would determine the fate of the company for the following month. Whereas, when you're in an environment like this, which is funded by the government has a real commitment to science, for the betterment of not just the UK, but the rest of the world. You do have pressure, you do feel pressure when you're working, and there are crunches, but it's not the same as when someone's just breathing down your neck for profits.
And just to back that up as well, because I similarly came from private industry, but not from software, from engineering, and I was making equipment for accelerators, and really very similar experience to what Lamar mentioned. The lack of a drive for profit means we can actually sit there and focus on our designs and make sure things work the first time. So you actually have the time and allowance and funding to do that, which is fantastic.
Yeah. Maybe if I can also ask another question a little bit different. For the timeline of the offers you presented today, is it something for like now, or how, let's say, when do you expect the candidates to start if they are successful in the interview process?
I'd say for most of the postings, if we have a posting live now, by the closing date, we would like to hire somebody as soon as we could after that. And then we obviously understand that if somebody has to go through a visa application process, that might take months. But that's not something that we would be opposed to. We invite that. But yeah, so anybody that has a job posting, they could start imminently.
Does anybody have anything? Yes, Kay, please go for it.
I think I was wondering if Haroon could say something about his transition from CERN and how he found that moving to ISIS.
Sure. So as a fellow at CERN, I was very focused on a very specific aspect of a single machine. So I had the opportunity to be laser focused and to grow in that area and to gain the expertise required to do such intense investigations, etc. But when I arrived at ISIS, I'm no longer focused on a very specific thing, and I have a very large umbrella of opportunity. And if anything, that's something of a curse, but it's a welcome curse, because I have the opportunity to try lots of new things, and then that means that my mind races and I have big plans, and I can do lots of awesome things. So in general, I think as a fellow at CERN, I was a specialist on one super specific thing, and here at ISIS, I have some major responsibilities that form sort of my journey as an accelerator physicist, but I am now on a permanent contract. I'm comfortable enough to sort of plan my future, which opens up a lot of other opportunities in terms of collaborating with other groups and thinking about, now I'm hiring my own staff. So responsibility has increased greatly. And I'm grateful for my experience at CERN, because that has taught me and given me a lot of benefits that I can now apply. So now I've been given the opportunity to do anything that an accelerator physicist can do. So I'm very happy to be in this position. Hopefully that answers your question.
I see Michele has another question. He's raised his hand. Please, Michele.
Yes, thank you. My question is for Catherine. Thanks for your presentation. Which is the rate? How many applications per position in average do you get?
That really varies across the different opportunities that we have available. So I would say for sort of engineering positions, we do tend to get fairly high volumes, sort of 40 to 50 applicants for those types of roles. However, for our more specific science opportunities, they tend to be slightly smaller in applicant numbers, probably because the uniqueness of the roles. But yeah, sort of varying from sort of 20 to 50 normally.
It's very reasonable. Here at CERN, we have 300, 400 per position. Thank you.
No problem.
Simona, please take it away. You have a question.
Yeah, so I just have a quick one regarding how is success measured, like if there is an annual performance evaluation, or how do you sort of measure that the person is progressing or moving to some goal eventually in his or her career?
Yeah, so we do an APR, an annual performance review process. So each employee works with their line manager directly, and that happens annually, but there's also a mandate that it happens twice a year, actually. So there's sort of a mid-year review to then check on those tasks. And it's the sort of thing where the employee develops their own plan. So an employee can set their own goals and agree on those with their line manager to then achieve those goals. So I think it works out really well.
Can I add something to that as well? So the APR process or the APR document is kind of like a living document. So it's not like something that you just pick up every 6 months. You kind of review it with your line manager, and as opportunities come up, it could be some kind of work opportunity or a learning and development opportunity. We're always keen to kind of modify things so that it gives you, the opportunity to develop or steer your career in the way you want to.
Here at CERN, we have a huge variety of different contract types, but is it correct that the vast majority of your contracts are, you say they're permanent? So how does that actually work, probation, etc.?
Yeah, so the majority of our contracts, particularly at the ISIS facility, are permanent. Probation periods are 6 months on average. They may sometimes be extended, but that's very rare, and that's only in extenuating circumstances. So the probation period is normally set at 6 months.
Okay, so that's quite a change from what we have here at CERN, where I think at the moment it's 5 years, and then for staff contracts at least. We have Simona and also Michele. So let's go with Simona first, and then next to Michele.
Yeah, I'm not sure if this was mentioned during the presentation, if there is a possibility for some internal mobility, if there are other projects that the person would like to join, and how difficult it is.
Yeah, I'd say there certainly is. I'd say it's fairly easy. Typically, we would do it if a group is looking to hire. We can open that up to internal candidates, and internal candidates can then apply. And if we really found a situation where there was a person that would be better suited and wanted to move to another group, we can sometimes make special arrangements. But it's not unusual, and it certainly happens. And I wouldn't say it's too difficult either.
There are also occasionally opportunities elsewhere in STFC. So for instance, in Accelerator Science, as well as ISIS, we have an Accelerator Science and Technology Centre that has some specialisms that we don't currently use for ISIS, but might be of interest for ISIS too. So there are definitely opportunities to collaborate and even to spend some secondment time elsewhere within STFC.
Thank you. Michele?
My question is for Galen or for John. It concerns the muon beam. Do you plan to cool down the muon beam?
So I don't think we do. We don't currently with our muon beam lines, but John, maybe you could discuss mice at all, perhaps? That might be the most related.
No, so the muon beams that we produce for ISIS are basically fixed energy, and that's what's required for the type of experiment we do. But we have also in the past hosted a thing called the mice experiment, which is muon ionization and cooling. That has now been completed, but did demonstrate the concept. But for ISIS, as a neutron and muon source, we don't intend to cool muon beams.
I have a less technical question. So I understand from the really nice video that you showed us that there are lots of opportunities for professional development, training, etc. I was wondering, do you also organize a mentoring scheme?
Yeah, we do. We've got a mentoring scheme, which is fairly easy to get involved with. I've sent people in my group to the mentoring scheme, and it's worked out really well. And I think we even just are introing a reverse mentoring scheme as well.
I was about to mention exactly that. Yeah, so I'm a mentor myself. I find that's been very successful. But we have recently, as part of our push towards ED&I activities, which Hannah might want to expand on, we have started talking about a reverse mentoring scheme where more junior members of staff, particularly who are from more diverse backgrounds, can mentor senior members of staff to make sure that they are learning the lessons from a younger generation.
So that's something that you're now launching, or you're in the process of launching?
We had an email from our executive chair yesterday announcing the launch of that scheme.
Wow, I'd love to find out more about that, but perhaps we can talk on another occasion about it. Thank you. What's the best way for people to contact you?
So I'd say the links in the presentations will work really well. You could also just reach out directly to us on LinkedIn. If you can search for us on LinkedIn, we should pop up, and that might be the second easiest way to do it. And then otherwise, you can apply for roles through the ISIS Careers webpage. Catherine, I think that would probably be the best.
Yeah, absolutely. I mean, we have a broad careers recruitment inbox as well, if you do want that, but that's across all of our opportunities. So it's not specific just to ISIS. So if you want any specific ISIS questions, I go through the channels that Galen's just mentioned.
Great, thank you. And Haroon, as a CERN alumnus, I guess people can contact you also via alumni.cern, because you can also give that perspective of having been at CERN and now working at ISIS.
Perhaps I can just highlight that ISIS is an existing facility that's been running for many years very successfully, and we published many scientific papers as a result. But we also have many opportunities in the future. So we will be expanding for our future in terms of ISIS-2. So hopefully this recruitment drive is just the start of many to come.
I'd like to say a huge thank you to Galen and Catherine for taking part, and also the other panelists from STFC for giving us such a great overview of what it's like to work at ISIS. Thanks ever so much to everybody, and have a lovely weekend.